Hey everyone, we're going to evaluate the improper integral or state if it diverges. We're going from negative infinity to infinity of x squared times e to the power of negative x cubed dx. It's improper because we have infinite integration limits. We have the upper limit's infinity and the lower limit is negative infinity. So that means we're going to use part 3 and write it as two different integrals. So integral 1 is like part 2. Integral 2 is this part. So let's separate this out and write it as equals to the integral from negative infinity to 0. So we have x squared e to the power of negative x cubed dx. That's going to be integral 1. And then for integral 2, we're going to write plus the integral from 0 to infinity. And we have x squared e to the power of negative x cubed dx. So let's start with this integral. This is integral 2. So we're going to have to use this formula for integral 2 and this formula for integral 1. So for integral 1, we're going to write this as the limit, and I'm going to use t. So t approaches negative infinity, and when you integrate this, we're going to get negative 1/3 e to the power of negative x cubed, and then we're evaluating this from t to 0. So this is going to equal, when you plug in 0, this is going to be 1, so you get 1/3 minus, and then when you plug in the t, you're going to get negative 1/3 times e to the negative t cubed. All right, so basically what we get is, for this part here, we still have to do the limit. So let me rewrite this. We're going to have 1/3 plus 1/3, and then we have to do the limit of this. So times the limit as t approaches negative infinity of e to the power of negative t cubed. Now let's look at that part. So when you substitute in a negative infinity, so when you have negative and negative infinity cubed, this is still going to be negative infinity because it's an odd power, and then you have the negative. So this is going to turn into e to the power of infinity, which goes to infinity. This just continues without bound. So basically, if I wrote this out, it's kind of funny looking, but if I write 1/3 plus 1/3, and this is going to go to infinity, this whole thing's just going to go to infinity. So it means it diverges. If one part of the integral, like integral 1, diverges, then there's no reason to do integral 2, because this is our integral here. If one part of this integral diverges, then so does then the whole integral here is going to be divergent. Thank you. Have a nice day. Bye-bye.